Hi and welcome back to the Mr. Talbot Maths video, and in this week's video it's this problem here. So we're working out the area of the square and we've got this diagonal that extends outside the sides of the square, and they are split up into these lengths 1, 3 and 2. Okay, if you want to have a go at this problem, pause the video now because I'm going to go through my solution in 3, 2, 1. Okay, so the first thing that I wanted to do is start putting on some angles here because I've got some triangles here. I've got 3 triangles, or 4 really, if you want to, well, depending on which ones you want to use. But I wanted to put these angles in. They're vertically opposite angles. So angles that are basically opposite of a vertex where 2 lines cross essentially, they will be equal. Now then I've got a right angle in this right hand triangle there with the hypotenuse of 2, so I put that in. Now I've also got this third angle. Now after that I've got this right angle at the top of this square, which I can then also use, just like I did with that right hand triangle, to give me the third angle. Now because 2 of those angles in those triangles are the same, the third angle must also be the same. And then I've also got in the smallest triangle on the left, I've got another right angle, so I'm also going to have another corresponding angle there. So I've made now, or identified really, 3 similar triangles. Okay, now once you've got those similar triangles, I need to start giving or labeling the sides, giving the sides a name, a letter. So let's call this side here X. Okay, so that's the height of the right hand triangle with hypotenuse 2. What I'm then going to do is, well, I'm going to use the scale factor. So this right hand triangle has a hypotenuse of 2, and if I look at the larger left hand triangle, which is like upside down, it's got a hypotenuse of 4. If I go all the way along, 1 add the 3 is the 4. So that has a hypotenuse which is double the one with a hypotenuse of 2. So that means the scale factor therefore is 2. And so the height of that triangle must be double using our scale factor. So that must be 2x there. Okay. Now, once I've got that, I need to basically find another way of finding corresponding sides. And because I've got this square involved here, then 3x must be the same as another side of the square. So I'm going to start basically looking at the left hand triangle now, and I'm going to call that side there y. Right, now again I'm going to use similar triangles with the smaller one, the left hand one with a hypotenuse of 1, and I'm going to use the same triangle I just used previously with the hypotenuse of 4, the 3 add the 1. And that's going to allow me to work out the length of the base. Now, going from a length of 1 to a length of 4 is a scale factor of 4. Okay, so I do y times 4 will give me 4y. So that would be all the way along the base of that triangle with hypotenuse 4. However, I've already got 1y there. So that length that I'm left with is going to be 3y. Okay, so that's just using similar triangles. Okay, now the next bit then is, well, I've got lengths of my square. I've got 3y and 3x, so they must be equal to each other because they're the sides of a square. So that gives us that y is equal to x. Now if we put that on the diagram, that's going to help us because now again using the triangle with hypotenuse 4, I have got a right angle in it, obviously. I can use Pythagoras theorem. So I've got the 2x and I've got the 4x, the 3x add the x. Okay, and that must be equal to 4 squared when you square both of those and add them together. So if we simplify that now, 2x squared is 2x times 2x, which is 4x squared, and 4x squared is 4x times 4x, which is 16x squared, and obviously 4 squared is 16. Okay, now let's tidy that up and collect our like terms. So we've got 20x squared equals 16, and then divide by the 20, and we get x squared is equal to 16 over 20, or 4 over 5 once you've simplified it. Now I could at this point have square rooted and got the answer of 2 over root 5, But I thought actually, because both my side lengths of, well, the side length of my square is in terms of x, then to work out the area of my square, I'm going to get an algebraic expression in terms of x squared. So I didn't actually need to square root it at this point. So I just started working out the area of the square, and the area of the square is going to be, well, 3x times 3x, or 3x squared, and 3x times 3x is 9x squared, and if I now substitute in my x squared, I've got 9 times 4 over 5, which gives us a final answer of 36 over 5 units squared. Let's put a box around it. Okay. I hope you enjoyed that problem, and if you're able to solve it yourself, please put it down in the comments so I can see your solution. Okay, I will see you next week for another Mr. Help Maths video. Bye-bye. Thank you for taking the time to watch my videos. I really appreciate it, and I really appreciate all the likes and everybody that subscribes to the channel. If you like this video, then there should be plenty more videos just up here. Hopefully it's here. That's where it should be, the one that you want to watch next. Okay, see you in the next one. Bye-bye.